the poor children who are going to be going 7th hour. Tennis or something. All right. This is going to be a very, very brief, shallow introduction to the periodic table. We honestly could spend an entire chapter talking about the periodic table and its history and when it got started and who are the famous people who developed it and all the contributions, all that great stuff. I don't know. I don't really go into that, so I'm just going to kind of talk about the periodic table we have today and how we interpret it a little bit. We're going to get into more detail in the next chapter of how to interpret it, but this will just be kind of our introduction for now, okay? So periodic table, okay? So we know that it's a list of all the elements that we currently know. How many elements are on it so far today? 118. 94 of them are natural, which means how many are synthetic? Quick math. A lot. 118 minus 94?
24.
24 are synthetic. Okay, so they are atoms and they do exist, but they're so unstable that they radioactively decompose and become other elements. So their nuclei fall apart, so that's kind of wild. But they do exist for a short period of time if you make them in a lab. Okay, so that's what I mean by synthetic. I think I get to use my laser today because I have to point at the periodic table. Okay. So the idea here is, okay, we get that it's like a table of all the elements, but why is it periodic? Okay, the idea is that periodic means repeating patterns. Okay, there are repeating patterns that occur in the chemical properties of the elements, and this is part of the significance of discovering that there's repeating patterns, and so that very directly informs the structure or the shape of how it's structured, because you notice it's not just like a perfect rectangle, it's kind of a weird shape, and that's on purpose because it's trying to communicate something about the patterns in the elements. So we'll talk a little bit about that once we get there. Okay. This is me glazing over like hours of lecture and research that we could do. Like, there's a large history and it's an ongoing thing. Okay, it's always being modified and improved. Anyone know when the last 4 elements were discovered or synthesized? How recently?
27.
Really recently, yeah. Literally in the last like 5-ish years. And then they were just named, was it 2020? They were named really recently. So this is obviously still a work in progress because people are still learning things, making new elements, all that good stuff. Okay, so this is what I mean by a living document. It's being changed. It has not been the same even in the last 5 years. That was weird. Cool? Cool. Okay. If you're a nerd, well, actually, if you're not a nerd, if you're in this class, ptable.com is a great periodic table online. I strongly recommend it. That's my go-to periodic table. Another fun one, periodictable.com. This one has like pictures of all the elements on there and stuff, okay? But ptable is really good. If you're gonna Google a periodic table, I would look up that one. That one's really good, has a lot of information. If you're a nerd, you can go to this website. This has a database of every single periodic table that has ever existed in the history of mankind. There are bazillions of them. It's kind of interesting to look at the history of the periodic table, but you can also see other arrangements of the elements. So that arrangement up there is not the only way to arrange the element. There's a bunch of other ways you could arrange them. That's just the most common. Okay, so for funsies, I'll just show you some. So this is like what we have, okay? Periodic table has this weird cutout in the top. We'll talk about that eventually. And then also the fact that there's 2 rows here that were chopped out. The only reason these are chopped out is to save space, so it fits on like a textbook page very nicely. I can show you what it, I guess what it technically should look like. ptable.com. My Mac is old and sad. It's not very quick. So that's periodic table what we're used to, but if you click on the wide setting, I'm going to scroll up, wide, this is what the periodic table actually should look like. It should include these two rows, and then even has a bigger cutout on the top there. But obviously this would be, like if you wanted to make a poster of this, it'd be a, kind of an awkward shape. Or if you want to put that in a book, also an awkward shape. So just for convenience, they do it like this, but it actually should look like that. So it's got those two rows at the bottom that are much longer, okay? So that's, oops, where's my slides? So that's what our periodic table looks like. But who's to say you couldn't arrange them, wait for it, like this? There are circular periodic tables where H is in the middle, and then you go around, and you go up, and then you go around, and you go up, and you go around. Okay, so they go in order that way. You could do a circular, spirally one. There are three-dimensional periodic tables that are also circular. Okay, so that's wild. Do I have another one? I don't have another one. There's other ones that are like shaped like a galaxy. It like spirals out, and they like put stars around it to make it look cool, but it's like spiral galaxy shaped. Okay, so this arrangement is just one way to do it. This is the most common. But I'm just showing you that there's a lot of different ways. And again, if you're a nerd, you can go to this website and look at all the fun periodic tables. Okay, so, but let's talk about the periodic table we have. Okay, so on our periodic table, we have sections or components of it called groups and periods. Okay, a group is a vertical column. Okay, so when I say group number 2 or group number 10, I'm talking about a vertical column on the periodic table. Anyone know how many groups are on the periodic table? Or if you don't know, can you count really fast? 18. Hey, look, they're labeled in red numbers. Okay, there are 18 groups on our periodic table. And that is significant, but I can't tell you until the chapter after this, so you gotta wait a month. Okay, but that's important. Okay. Now, the fact that certain elements are in the same group is significant. It tells us something. And the simplest way I can say it is that they have similar chemical properties. So, for example, if you take all the elements in group 1, the fact that they're in that group together says something about how they behave chemically. And it really has to do with how the electrons are arranged in the cloud. You guys know what happens when you throw pure sodium in water? It reacts with the water and like makes a big fireball, fun stuff like that. Same thing with lithium, same thing with potassium and rubidium and cesium and francium. Okay, they all react with water and form similar compounds from that water. Okay, obviously not the same because they're different elements, but similar. So they're chemically similar, and you could say a lot of the same things about other elements that are in the same group. Okay, so same group, similar chemical properties. Okay, another thing that we'll unpack later is they have the same number of valence electrons. Okay, we'll unpack this more as we go. Okay, but what that means is the high energy electrons that form chemical bonds are going to be similar if the elements are in the same group. Okay, I'll just say it now, we'll unpack it later. Okay, so I have 18 groups, but I also have rows, right? Horizontal rows. Those are called periods. Potentially trick question. How many periods are on the periodic table?
7.
Is it 7 or is it 9? Daniel really thinks it's 7.
It's 7.
Anthony also thinks it's 7. What about those two down there?
They fit in.
There you go. Okay, that's the key. They fit in with period 6 and period 7. So part of it is chopped out. Some people think it's 9, but it's actually 7. There are 7 periods on our traditional periodic table, if I could say it that way. Okay, elements in the same period have the same number of energy levels, okay, in their cloud. Again, we'll talk about that later, but I'm just saying it so you at least heard it once. And by energy levels, I mean, I'm talking about the electron cloud where the electrons are, right? They have different energies. Really, the main thing I want you to know is there's 18 groups, there's 7 periods, and elements in the same group have similar chemical properties. That's like the biggest takeaway from this slide. So we're just talking about how it's structured. Am I standing in people's way? Can you guys smell my candle? I can't tell if it smells strong or not. No? Yes. Okay, we good? Okay, let's talk about different regions of the periodic table. So we can classify elements based on physical properties and chemical properties. If I want to classify the elements based on physical properties, what I mean by that are what properties does this element have on its own? I'm not going to react it with anything. I'm not going to combine it with any other elements. I just want to know what properties does it have sitting on its own. Those are physical properties, okay? What color is it? Does it have a smell? Is it a solid? Is it shiny? Is it not shiny? Does it conduct electricity? Does it conduct heat? Those kinds of things are physical properties, okay? And if I do that, what we find is there are 3 categories that we kind of find, okay? We have metals, which kind of weird to think most elements in the universe are just metals. They're gray metals. There's a few that are not gray, right? Copper is copper colored, gold is gold colored, but pretty much all these other are just shiny silver metals. Okay, so I've got metals, and then on the other end I've got non-metals, so I got a few of those, and then there's these weird elements that are metalloids, and it's not that they have properties in between, it's that they have some properties of each. They're a weird combination of, they have some metal properties and some non-metal properties. Okay, so we'll talk about those. Okay, so let's talk about metals. Okay, here are some metals. Very cool. What metal is this? Copper. This is a liquid metal at room temp. Anyone know this one? Yeah, it's mercury. It's kind of fun. I need to buy some of this stuff, but apparently it's like toxic and they don't let people buy it, so. But my chemistry professor had some, and he had it in a little vial. He passed it around. It's weird because it's like obviously a liquid, but then you like get it in your hand. It's like heavy. It's like this heavy liquid because it's metal, so it's really weird. Mercury. What are soda cans made of? Aluminum. Forgot what that is. Forgot what that is. Okay, cool. Metals. Oh wait, they're labeled. Vanadium, iron. Why did I not label the bottom? Maybe because those are obvious. Okay, iron and vanadium. Properties of metals. How could you describe metals? 6th grade science. Shiny. What else?
On the left side of the periodic table.
Correct, they are on the left side of the periodic table. I guess technically like left and the center. Physical properties. If you just have a metal sitting on the table, what can you observe about it? Besides shiny. Solid, good. What else? Opaque. Okay, so there's one. Solid. If you handle it,
That's heavy.
does it, okay, it's
Hazmat.
could be heavy, or maybe dense is probably a better way to say it, because I don't think aluminum foil is very heavy. But as a ratio to its volume, it's pretty heavy, so we would say dense. Does it break and crumble, or does it bend? It bends. We call that malleable or ductile. Okay, malleable, ductile. They're also good conductors of heat and electricity. Malleable technically means you can flatten it and make like foil out of it. So obviously we know about aluminum foil, but you can get gold foil, lead foil, like those exist. Ductile means you can extrude it out and make wires. Okay, but they're kind of talking about the same thing. You can apply force to it, and instead of breaking under force, it bends or flattens. Okay, good conductors of heat and electricity. Okay, so we kind of know this, but just coming back around to it. Great. Then we have non-metals. Okay, so different periodic table. Okay, but non-metals are over here. Those are on the far right side of the periodic table. There's not as many of them. There's like 20 of them. I don't know. Okay, non-metals might look like this. Anyone know? Can anyone identify any of these? Okay, neon. There you go. Easy one. Huh? Iodine is here. This is iodine, so iodine's kind of fun. It's normally like a grayish, dull gray color, but when you heat it up, it turns into a purple gas, and it like floats away as a purple gas. So that's pretty wild. So that's iodine.
Yellow one's sulfur.
Yeah, yellow is sulfur. Okay, so that's sulfur rocks. We're actually going to do a lab, and we'll get to look at some of these. So this will be cool. I have sulfur. It's kind of fun. Ashes. You know what ashes are made of? Carbon. So that's carbon, and then this is phosphorus. Okay, and this picture is probably taken under glass because phosphorus will just like react with air and burst into flames, and you actually can't put it out. So kind of crazy. So those are non-metals. Okay, non-metals are on the right side of the periodic table. Okay, basically all of their physical properties are the opposite of metals. So they are not shiny, right? I call it matte. You could also say dull is another way you could say it. Typically a colorless gas, not malleable. So the word for not malleable is brittle. So if it's a solid, right? If you notice, you go back here, it's crumbly. Okay, if you apply enough force to it, it breaks. Okay, now that's not to say that it's easy to break it. Sometimes, you know, if you have a big chunk of sulfur, you can't break it. Brittle doesn't mean it's easy to break. It means what happens when you apply enough force. Will it bend eventually, or will it break and crumble? Brittle means break and crumble. Okay? They are poor conductors of heat and electricity, aka good insulators. Yes.
Porcelain. That would be non-metal, but
Porcelain. So that's a fun one. That is not an element.
oh, it's not.
That's a combination of elements, and so it kind of doesn't really apply to this. But yes, it would be a non-metal, but it's not a non-metal element. It's a non-metal compound because it's a combination of elements. So
I don't know, because those are good insulators, like on
yes.
electric.
Yep. And the fun thing about that is porcelain is actually a combination of metal atoms and non-metal atoms, but when you put them together, it has the properties of a non-metal. So, but yes, because of that, we go with this. Okay. So then metalloids. Okay. So metalloids are these elements that are kind of in between. An easy way to remember which ones are which is you draw a line between aluminum and boron, like that, and then you make a staircase going down. Notice how all of the metalloids are touching that staircase, and then the only ones you leave out are aluminum is obviously a metal. We all know about aluminum, and then polonium is not a metal, or I'm sorry, not a metalloid. So then the other, what is that, 2, 4, 6, 7 elements on that staircase are the metalloids. Okay, so that's a way you can remember which ones, because up there you can't really tell. Just draw a line right here and then staircase down, and that's how you can remember. Okay, so metalloids. Metalloids are cool, they're very useful. Arsenic, super poisonous, people die or commit homicide with it, so that's fun, I guess. Super poisonous. I think this is silicon, okay, which is used in computer chips, so that's interesting. And then, don't remember what that is. Did I label it? I did not, that's unfortunate. I'm gonna have to re-Google that one. But notice what we have here. So, it's shiny like a metal, right? It's reflective. Arsenic looks shiny. But look, it's crumbly, like a non-metal. So here's the thing I want us to remember, is metalloids don't have properties in between. It's not about being in between. It's they have some properties of metals and some properties of non-metals. It's a weird combination of them. It's not that they're in between. It's that they're combining both sides of that spectrum. Okay? Have properties, and I literally just typed it wrong on the slides. Some properties you can tell that I taught this wrong 3 years ago, but now I teach it right. Wow. And some. If you were giving a presentation in class and you had to fix your slides in the middle of your presentation, you think your teacher would like that? And yet here I am. Okay, so they can be somewhat shiny. They can be either brittle or malleable depending on depending on the compound. And then here's the key here, they are semiconductors. They do conduct electricity, but not as freely as a metal would. And they could be kind of insulating, but they're not as insulating as... They're not as insulating as a non-metal, which is kind of weird. But turns out this is actually really useful. When you are making computer chips or things where you need a very precise control of electricity flow, you want something that is not just going to let it run freely like copper. The silicon, which is what we use here, is going to be more useful for that. So the semi-conducting aspect of it is actually kind of nice because then you have more control over how it functions. Cool? Okay, I'm winding up. We can also classify elements by chemical properties. Okay? And this has to do with the electrons. How do they behave in a chemical reaction? Okay? So we've got main group, transition metals, and then the inner transition metals. These are also called the lanthanide and actinide series. So lanthanum is right here, and actinium is right here. So that's the lanthanide series and the actinide series. It's more what they're most commonly called. Okay, here's the story with those. Okay, if I have main group elements, so that's in groups 1, group 2, skip 10, group 13 through 18. 1, 2, 13, 14, 15, 16, 17, 18. Okay, these elements have a pattern that is very predictable, and we're going to talk about these patterns probably tomorrow. Okay, their chemical properties follow a very predictable pattern. And the elements in each column make the same charge. I'll go ahead and show you the pattern for how the charges work. This will be a throwback to physical science if you remember that. Elements in this column obviously could be a neutral atom, but when they become an ion, most commonly they make a +1 charge. Elements here could also have a neutral charge, right? Anything could be neutral, but when it becomes an ion, it typically becomes a +2 charge. Okay, so there's a pattern. If you're in the same column, you have similar chemical properties. Becoming an ion is a chemical process. Okay, skip those. We're going to come over here. These guys make a +3. These guys could be +4 or -4, depending on the situation. -3, -2, -1. The elements in group 18 typically don't become ions. They're always 0, pretty much always. Okay. So we'll talk more about this pattern, but I'm just showing you there's a pattern. All of these elements in the same column like to become ions of the same charge. It's kind of interesting. These other elements don't follow a pattern like that. It's a little more complicated. Okay, but the main group, that's a very easy pattern. 1, 2, 3, 4, 3, 2, 1, 0. Right? Positive and negative. So that's an easy pattern to remember. Very predictable pattern. The transition metals, on the other hand, are not so nice. Okay, those are in the middle, 3 through 12. Okay, they can have multiple charges. So, for example, iron is an element, and it could become a +2 or a +3. It very commonly has different charges. Chromium is crazy. Chromium can be like 10 different charges. So I can't like put a periodic table up here and be like, these elements make this charge and these make that charge in the transit. It just depends on the element. So it's more complex. Okay, and they're kind of fun because they form colorful compounds. So this is why you guys heard of lead paint, right? Lead is a transition metal, or it's a post-transition metal, but it makes really colorful compounds. And so why wouldn't you make paint out of something that makes really cool colors? Oh wait, it's toxic and makes people sick and they die. Bummer. But transition metals allow us to make really colorful things. The other elements we just talked about, the main group elements, are super boring. They don't make cool colors. Okay? So. And just to clarify, the elements are not this color. The element reacting with other elements can make these colors. But you can only get it if there's a transition metal present in the compound. Okay? So there's not like a purple element. This probably has manganese in it. Manganese reacted with something else. But you still get the colors. Okay, so that's kind of fun. Also, fun fact, our magnetic elements are in the transition metals. Iron, cobalt, and nickel are the only elements that are magnetic or ferromagnetic on their own. You can make magnets, different types of magnets, and things with other elements, but if you think of just like a typical magnet, these are the only three elements. Okay, where are they on the periodic table? Just find them. Well, they're in the middle, but more specifically, are they close to each other?
Yes, they're like right next to each
They're right next to each other. 26, 27, 28. Yeah, they're right next to each other. So that's kind of fun. So our three ferromagnetic elements are in the transition metals. Okay. The lanthanide series and the actinide series are also called rare earth metals. Basically, I never learned about them. They are a very, very niche part of chemistry, and I have an entire bachelor's degree in chemistry, and we did not talk about them once. Okay, so I do know that people have studied them. They know a lot about them. You have them in your phones. They're used in phones and all that kind of stuff, but I personally don't know a lot about them. So the only thing I can tell you is they're mostly synthetic and they're radioactive. Some of them are. Oops. So that's a fancy way of saying, I don't know much about them, but they're a thing. If you're a nerd, you can go to the periodic table website and learn about periodic tables, and if you're a nerd, you can Google them and teach me about them, because I have not learned much about them. Okay, I'm almost done. Thanks for hanging. These notes took longer than I thought they would, but. Last slide. There are special names for 4 of the groups on the periodic table that I would like you to know. Okay, group 1, group 2, group 17, and group 18 are categories of elements that are used commonly enough that they have, those categories kind of have their own name. Okay, so group 1, those are called alkali metals. So if I say alkali metal, I'm talking about a metal in group 1. I guess technically hydrogen is not a metal, so it's technically lithium through francium, but it's in group 1. Alkali metals. Group 2, these are called alkaline earth metals. That's group 2. These ones, I guess you've heard of them. This one starts with H. Does Daniel know? What is it? It is the halogens. Group 17, those are halogens. What you got, Tate? Noble gases, that's it. They are called noble because they do not typically react with other elements. They're better than anyone else, and they don't associate with the common people. They stick to themselves. That's literally why they're called noble. It's because they don't react with anything, and humans like to anthropomorphize or personify things, so it's like, oh, well, they just think they're better, so they don't react with anything, so they're noble. Funny name, but that's where it comes from. Cool? Questions? Okay. We have 8 minutes, and I have a big worksheet. How about we do it tomorrow? Instead of homework? Sound good?
Yes.
Sweet.